Hi, and welcome to Introduction to SBOM using software bills of materials for AppSec and compliance. I'm Darren Meyer, and once again, I'll be your host. We talked in the past few sessions about SBOM as a document that represents a software inventory. So in order to be effective, you have to be able to create and manage that software inventory. So what does that look like? To start with, we have to discover the components that we have. And these typically live in one of two places, in source repositories or in package repositories. And it is important to understand the differences between those things. A source repository like GitHub or GitLab, these are places where you're storing your source code for this first-party software that you're writing. And sometimes, occasionally, some third-party software will also be in your source repository. But this is primarily storing source code. Now, source repositories have advanced quite a bit, so sometimes the line between source and package can be a little bit blurred. Places like GitHub and GitLab also have package repositories, so you got to be a little bit careful with this. But inside the source repository part of these things, you have repositories individually as kind of a unit of analysis. But you got to be a little bit careful because while often a repository houses a project, it's not always a one-to-one relationship. There's other patterns. There's a pattern called a polyrepo pattern, where you have a project or an application, or when you kind of think of how you organize software, might consist of many repositories working together. That's a polyrepo pattern. Or you might have many projects in a monorepo. If you want to go true monorepo, places like Google will have one monorepo that houses all of the core products in the organization. It really can be just one thing. And so you have many projects, even though you only have one repository. So when you're looking for projects and you're looking for software components inside these source repositories, you do have to bring a little bit of awareness that a repository and the components that you're analyzing aren't going to be one-to-one. And of course, access to these things does vary by organization. Sometimes you as a product security or application security practitioner do get read access. A lot of kind of modern software first organizations, modern software companies, for example, everyone gets read access. Doesn't always happen. In a lot of larger, more enterprise, more well-established organizations, you'll have a little more resistance to security teams getting access to these repositories, especially across business units and things like that. So ideally, when you're building an inventory and you're doing your component discovery, you want to kind of scan through these source repositories, but you may need help to do that. You may not just have the access already. You may need the participation of a DevOps team or a development team, or more than one in some cases. Now, when I'm working as a developer and I build software inside a source repository, I use a pipeline typically. Something like 80% of people now are building in an automated pipeline. And the end result of this build is very frequently a package, right? And that package can be pushed to a number of places. Sometimes it can live right on something like GitHub. Sometimes it's going to be in an S3 bucket or in a file system somewhere. Sometimes it's going to be in a public repository. So something like Maven or PyPI, which are Java and Python sort of artifactories, as it were. An artifactory is another example of something that you might host yourself internally. There's also package repositories for operating systems, right? Red Hat's got a repository for the Red Hat Package Manager, right? Actually, several repositories. If you're a big Ubuntu or a Debian fan, those packages are coming from Ubuntu's or Debian's repositories, and maybe those hosted by other vendors and things like that. And what you're mostly going to find in these package repositories is third-party libraries and sometimes whole applications. But if you're running your own artifactory or you're working on something that is open sourced, you may actually have your packages out in a package repository as well, either a private one where only your organization has access, or a public one. So this can be a little bit difficult for discovery because you're not going to look at all of PyPI and say, you're going to find every Python package in existence, right? You're clearly not using all of that. So you have to kind of figure out, like, where are my packages coming from? When are they being used? It can be somewhat complicated for discovery. So you're going to need help of DevOps and other teams to help understand, like, where are these things getting consumed and deployed? And some of these items in inventory are only ever going to be in package repos. So sometimes you'll see a source repository and a package repository. That always makes your life easier. But sometimes things you consume are only the packages, right? a lot of your dependencies are only going to be in package repos. Sometimes an application that you're deploying, the only visibility you're going to have as a security team is a package repo, even though it technically probably exists in a source repo somewhere. And of course, because life can't ever be simple, there's another layer to this, which is there's stuff that doesn't live in a repository at all. So when you're using tools and you're building programs to go out and kind of automatically discover components in repositories, keep in mind that some things don't come from there. Now, your standard software composition analysis tools and container scanning tools and other things that are kind of supply chain security focused, a lot of times will do this discovery for you for repositories. If you give them a little bit of information about where your repositories are, a lot of times these things can auto-discover what you're being used. But things that have no repository require other kinds of inventory tools. You'll have things like CNAPP tools for the cloud. There's tons of equivalents. There's a huge space of trying to get on top of software inventory. Now, fortunately for us as practitioners, this software I'm getting from no repository is becoming less and less common in terms of your core products. Still very common for desktop software and things that people are using. But this no repository pattern is shrinking over time. So it isn't where I would put my time and effort first, but it is something to be aware of because it still does represent risks. So that's kind of the places where you're going to find your software inventory. So, but what do I need to look at in and of itself? For that, we're going to go a little bit further down the pipe. For that, we're going to go a little bit further down the pipe. We want to find all of your classes of dependencies too. So I found all the locations. Now I want to find every class of them. And this gets a little tricky because a lot of security tools, a lot of enumeration tools, they focus on these two things that have the bolded line here. Open source libraries that you're getting from some public package repository or from GitHub or whatever the case may be, and private packages that you produce in-house, first-party things, sometimes second-party things, which would be produced by like a business partner, things like that. They're typically not as good at finding like things like commercial libraries or whole applications that you're bringing into your environment or cloud services that you're consuming. Now, there are different security controls in the world that do have discovery features for some of these. CNAPP platforms, for example, for cloud native applications, often will do discovery of your cloud services that are third party as well, up to a certain point. There's always some degree of limitation because there isn't a universal discovery standard for these. But if you're using pretty standard things, you can do a lot of discovery that way. Same thing that there are, application inventory programs. Some SCA tools are aware of commercial libraries, at least to some level. You may have to enumerate some of these things by hand. Now, fortunately, commercial libraries are becoming less and less common. Most of the time, if you're using a library that's, even if it's not technically open source, it's technically commercial, a lot of times it will be available in the public repositories that also host all your open source libraries for ease of distribution. So that's a use case you have to worry a little bit less about over time, but it is there and it's important to be aware of it. And then, of course, we want to be able to find all the different kinds of relationships as well. So class is kind of type, right? Where am I getting this from? Getting it from a repository. It is the type open source library, but I have to worry about the relationships it has to me too. And this is where things can get a little confusing. If you're not familiar with how dependency management works in software, this can be a little bit odd. And when I say a little bit odd, I mean, there are definitely complexities, and it's very hard to really show a full view of how complex it can get. But when you have your application, you have these direct dependencies, and that's where most people first start looking, right? That's the obvious thing. These are things that my developers have chosen to use. They're open source libraries, for example. 80% of them probably are open source libraries that the developer has said, I want to use this thing, and they've gone and created a manifest file in their code and said, I want to use package foo. Great. That's important for me to know. That definitely goes into my software inventory. It's relatively easy to discover, although you have to watch some composition analysis tools, even some of the very good open source ones, kind of struggle a little bit with accurately identifying these things in certain circumstances. So you do kind of have to spot check your tools. Tools are not perfect ever. Perfect inventory is really hard to come by. You can get very, very good And to get very good, you really need to use tools, but you do need to spot check and audit your tools to make sure they're giving you good enough, reliable enough results. But then there's these dependencies that I didn't necessarily pick. They're not necessarily in my manifest. And there's two ways that can happen. One is transitive dependencies. See, so like I wrote an application and I picked foo and bar to use as my dependencies, but foo is a software component too. And their developers aren't writing everything from scratch either. Why would they when they have all these open source libraries to pick from? So they're going to have their own dependencies. In this case, the developer of foo picked a dependency called bat. And bat is its own dependency. And they picked a dependency called bats. And this can go on and on and on. Those things that your developers didn't pick directly are called your transitive dependencies. They have this sort of transitive relationship to your application. They represent risks just like anything else, and they are part of your software inventory, just like everything else. So not only do you need to find these and identify them and get them into your bill of materials, but you also need to identify the risks and get them into your VEX document if you're going to use that to analyze and exchange vulnerability information and annotations, right? There's also this little weird tail that you'll see off to the left here that is labeled Phantom. This is a thing that often skates by. Many tools are unaware of it. Many practitioners are unaware of it. Many developers, like, they're aware of it if you have a conversation with them, but it's something they might not think about. This happens a lot in AI, by way of example, where you will have applications that say, hey, I have all these libraries declared. Oh, and by the way, please install TensorFlow before you install me. Well, that's still a dependency. But most scanning tools are going to look at, the manifest files that developers have created that identify the direct dependencies, and TensorFlow won't be anywhere in there. And none of those libraries rely explicitly on TensorFlow either. So they're not anywhere in this direct or transitive dependency tree that something like Maven or something like an SCA tool will show for you. So they're very difficult to automatically discover. But in the real world where it's installed, there's a prerequisite. And some IT person, some deployment expert, some DevOps engineer has to make sure that the environment where your application runs has these dependencies installed. Sometimes they're operating system dependencies, sometimes they're libraries like TensorFlow, things like that. So it's very important to make sure that you find those phantom dependencies. We call them phantom because they're not listed anywhere in any kind of manifest. And if I just go and, if there's a Python application, I pip install this application, right, which is supposed to install all my dependencies, it doesn't install this phantom dependency. So it's very difficult for an automated tool to pick up on these things. There are a few that do it, but it's very difficult to do. And so many tools ignore this problem or aren't aware of it. And, if you ask your developers, hey, do you know what your phantom dependencies are? They'll kind of look at you funny. It's not a term of art that's very common in software development. But if you're like, hey, is there anything that you have to install before you run the installer for the application? And for at least some of your applications, they're probably gonna be, oh yeah, actually, we have to install, TensorFlow. I keep bringing up TensorFlow. It's a really common one that people don't, it's a big package, so people don't want to put it in their manifest. They just expect it to be installed, right? So it's those kinds of things that are just sort of expected to be installed. And so like that whole chain now is I have to find out where all my packages are, what they depend on, and what kind of package they are. Are they open source? Are they first party? Are they commercial? Are they applications, right? So I have to build that entire map to really get a complete bill of materials. SCA tools will automate kind of this level for you if they're good tools, but there's always that little tail of things where you're going to have to add other tool chains and other inventory efforts to make sure that you can really have a complete inventory of everything, especially if you have a compliance requirement for it. And having it isn't enough. You have to maintain it, right? And that's where tools really come in my opinion. You can't really keep things up to date without tools. You can build the inventory without them. It's a lot of work, but you can put human beings on it. You can use little open source packages, little tools to help you. If you just need a point in time inventory across your whole organization, you could probably get that, depending on the size of your organization, in a few hours or a few days. But you're not going to be able to dedicate your application security team or a DevOps resource or whoever in order to do that project on a continuous basis. This is just not tenable. And in the modern world, we release software and update our software so fast, you really, really genuinely need tools to keep this stuff up to date. So container inventory tools, SCA tools, CNAPP, those kinds of things are absolutely essential. And you need to kind of put them into the development process, right? They can't just be something that runs off to the side every once in a while. That's not a terrible place to start if you've got nothing. It's not a terrible place to start to operate in what I like to call supervisor mode, where I'm sitting outside of the development process and I'm just sort of every day or every week or on some cadence, I'm running a set of scripts that goes out and enumerates everything. It's a heck of a lot better than nothing, and it gets you up to speed really quickly. But if you really want accurate, up-to-date inventories, you really got to kind of insert yourself into the dev pipeline at some point, right? So you're going to be in your continuous integration environment, and in that CI environment, you're going to have some kind of a pipeline automation, either integrated with the build or kind of off to one side that says, hey, every time that I'm cutting a release, every time I'm doing something that I need an updated inventory for, I'm going to discover and update that inventory, right? So that I can have an accurate SBOM. And where you can't do that kind of scanning, you definitely need to have that pathway to be an SBOM consumer and import them wherever you can. And that's why it's so important to start asking your vendors for SBOMs and start looking for projects that aren't scannable. For most open source projects, you could always scan them the same way that you scan your first party code, but you can't always do that for commercial applications. Even when you technically can, a lot of times the license restrictions are such that you're not really allowed to do it. Could be legal risk, definitely something to check with your legal team if you want to go down that path. But ingesting SBOMs is much lower risk, is much more straightforward. And the whole point of doing this is that every time you release, you need to update your inventory. Because if I'm asking you for an SBOM as a consumer, I want that SBOM and the VEX that goes with it to be up to date with the thing I'm actually going to run. So at minimum, this needs to be updated every time that you cut a release. And that SBOM needs to be tied to that release somehow. Tools are starting to make this easier through doing things like signing SBOMs. CycloneDX has, linking capabilities, so you can link an SBOM to an artifact a little bit more reliably. But there's going to be some process and some database work that you have to do to make sure you can say this inventory represents this version of this software at this time, right? And because this scanning process is involved, like in order to do those things that we talked about with relationships. So if I pop back one step here, in order to do this, your tool has to be aware of a fair amount of things to do this accurately. It has to look at what your various package managers are doing. It has to look at, can't just look at manifest files or lock files some tools will look for and get accurate results. It has to do deeper analysis than that. So as long as you're in there doing the analysis to uncover this whole relationship graph, you're also going to want to do risk analysis, right? That's a good time to do it. For first party and third party, like open source libraries, SCA tools do a really good job of this. Most of them are built to do this automatically. They're not just going to build an inventory, they're automatically going to start looking for risks as well. At the very least, they're going to look for known vulnerabilities. Good tools look for other risks that you might worry about. Right? And there's a lot of things on the market. You have to compare very carefully for things that are going to meet your needs and kind of assess the risks that you care about, right? And you really need to constantly monitor those risks too, because we talk about this a lot as these events, right? Keeping up to date of, I released software, I changed my software, therefore my risks might have changed. That's true. That's kind of, baseline, I have to do this. But there's the second piece of that, which is sometimes it's not your software that's changed, sometimes the world around you changes, right? I guarantee that for any reasonably complex piece of software, there's an open source library in there somewhere that it relies on that has a vulnerability that hasn't been discovered yet. So you're going to release that, and maybe it's weeks, maybe it's months, maybe it's years, right? Down the road, someone's going to discover a vulnerability in there and publish it. Now, if nobody's running that anymore, no worry for you. But if it's a week after you released and it's the thing currently in production, you need to know. So you also need to kind of continuously monitor the risks to the inventory you have, which is a slightly separate problem than monitoring the inventory itself and keeping the inventory itself up to date. And again, this is something that good SCA tools and good CNAPP tools, good inventory tools already do, but it's not always automatic. Sometimes you have to explicitly say, hey, this particular time and place that I scanned, that's a thing I want to monitor. So make sure you understand how your tool handles this problem, because it's not always automatic and it's not always in the way that you expect it. So kind of as a general summary here, what we're trying to get down to is we've talked about, representing your inventory as a document as an SBOM, representing the risks as a document that is a VEX, being able to use that to communicate what you've learned about your risks, being able to annotate things like, if you have a more advanced SCA tool, it might do some kind of analysis like, is this exposed to the internet? Or is there a function call path that's reachable? Or one of those things kind of helps you get some context to the risk. You can represent that in VEX as well, which helps communicate with your auditors. And you have to generate that stuff. You have to generate it at least every release, sometimes more often, depending on your use case. And you also need to be able to kind of keep track of the things that represent active things. If you're a cloud company and there's only one version in production, that's relatively simple. You need some retention history for, what if somebody had a data breach in the past and we only discovered it now? You need it for investigative purposes, but you don't need to go back forever. But if you're distributing software, how long does people have these things? Some cases years, right? You need to make sure that you have and retain those SBOMs, that the inventory is complete, that it's automatically updated, and that you're identifying risks as you go for all of those relationships and all of those sources. So it's a big ask. It's not just about creating the SBOM document. It is about managing a software inventory and representing it effectively to people. I hope you enjoyed, or at least found this informative over the course of things. We'll have one more little summary coming your way, and to wrap things up. And you can look forward to an advanced version of this that talks more in depth about the producer and consumer roles and all of the detail that you might want to engage in as a producer or consumer of SBOMs and VEX documents. Thank you very much.